So far we have discussed the motion of solids. In this chapter we will be learning about the mechanics of liquids and gases. First thing I want to do is get rid of a common notion, okay? Most people associate a fluid with a liquid. They think of those two terms as being the same, okay? They're not. A fluid could be a liquid, but it could also be a gas. Anything that is a fluid has the ability to flow or to change its shape. So it'll take on the shape of its container. You stick water and other liquids into a container, they take the shape of their container. However, they'll only fill up so much of the container, okay? A gas, fill up a container with a gas, again, it's going to take the shape of the container, but it's going to fill the entire space. So that's how they're a little bit different. But no matter what, they're changing their shape to fit the container, okay? So that means they can change their shape. That makes them a fluid, okay? Liquids have a definite volume. Gases do not. Again, gases will expand to fill up a container, okay? Density. Density is your mass per unit volume, okay? It's a measure of how close the atoms are together. Now, we say this. We're talking about mass density, okay? Maybe on TV or in a history class somewhere you've talked about population density. It doesn't have to do with how much mass something has. That has to do with how many people are in a certain area, okay? And there's also charge density. But for this chapter, when we use the word density, we are going to be talking about mass density, which is your mass per unit volume. And again, it's a measure of how close the atoms are together. So gold has a density of 19.3 grams per milliliter. Okay, so that's the density of gold. Aluminum has a density of 2.7 grams per milliliter. Okay, this means if I have 1 milliliter of gold, it's going to have a mass of 19.3 grams. If I have 1 milliliter of aluminum, its mass will be less at 2.7 grams. Okay, so that means I've got more stuff packed into this milliliter. It's more dense. Okay, and how does it get more packed together? Well, the atoms get closer together. Okay. Now, you're going to see this, however, down here in physics, we are going to use kilograms per cubic meter, okay, not grams per milliliter. So we need a little conversion factor, okay? So 1 gram per milliliter is equal to 1,000 kilograms per cubic meter. So that's our conversion factor. So this would simply be 19,300 kilograms per cubic meter. And this would be 2,700 kilograms per cubic meter, okay? And as we were up here, you may have seen me using the symbol for density, which is the Greek letter rho. It looks like a combination of a lowercase p and an e, okay? Kind of think of it, all right? And it is the mass divided by the volume. A lot of times talking about density, we talk about, hey, was something going to sink or is it going to float? So how do you determine this? Well, if an object is floating, then that object's density is less than the density of the fluid. Okay? So let's say we have our aluminum again. Okay? And the density of aluminum is 2,700 kilograms per cubic meter. All right, and I take this aluminum and I stick it in water. Well, the density of water is 1,000 kilograms per cubic meter. So if I've got my aluminum and I stick it in water, this is not less dense, it is more dense. So in this case, the aluminum is going to sink inside of the water. Okay? However, if I take this same aluminum with a density of 2,700 kilograms per cubic meter, and instead I stick it into mercury, which has a density of, and it's bigger than 2,700, then it would float.